Hi there and welcome. Today I got a 2011 Chevy Camaro. I'd like to do some lab scope traces on it, do some testing of some various signals. In case you're not familiar with the use of an oscilloscope for automotive diagnostics, I thought I'd bring you along, let you see what's going on, show you my hookups, show you the trace patterns. There's no problems with this vehicle, but I thought I'd take this opportunity to get some known good waveforms that I can save to my library for future reference. When troubleshooting computer-related issues, I think it's important to know when using an oscilloscope what a particular signal should look like. I'd like to tap into the crank sensor and the cam sensor so you can see what they look like. I'd also like to take a look at the foot pedal position sensors and the throttle plate feedback sensors, or the TPS 1 and 2. We'll also grab the U scope and plug that in and see what the traces look like compared to the pico scope. I'll show you my connections. We're going to go right at the PCM on this vehicle because it's very accessible. It doesn't make a difference if you use the PCM or go right to the sensor. I like to use the PCM connector because I'm testing the sensor operation itself and the integrity of the wiring harness between the sensor and the computer. So I'm doing my initial setup on the scope here. We'll set our sensor readings to plus 5 volts, plus or minus 5 volts. It's important to know what your sensor output should be. You'll find out here shortly that these were a little on the low side. We'll go ahead and run the scope. Now we're looking at some live voltage traces. All we need to do now is just go start the vehicle or activate the circuit to get our live readings. And you'll see here that they're off the charts. But I am acquiring a signal. What I need to do now is go adjust my voltage range to get that within a reasonable level. I'll drop these down to a plus or minus 10, I believe. You'll also notice the crank sensor has a lot of spikes hanging off of it. Pretty normal for an oscilloscope trace to catch a lot of noise. Pico does a nice job of including filtering. Here I adjusted the time-based setting to get more on the screen, a little too much I'm thinking. I'll readjust that. Okay, so you can see the crank signal and the cam signal overlaid on each other. Here I'm going to add some filtering. You can see how that cleaned up the crank sensor real nice. I'll do the same thing here for channel B on the cam sensor. Now the signals look a lot cleaner. And here I'm separating out the signals so they're easier to see. I'll stretch this out a little bit more so we can see more of the cam signal. We'll stop this and save it to our library. And that is about it. We now have a known good waveform for the cam and crank on a 2011 Chevrolet Camaro. For those maybe not too familiar with using an oscilloscope, here's another alternative. I'd like to show off the U-scope a little bit. It's a single channel scope, currently connected to the crank signal. Again, there's no problem with this vehicle. I just wanted to take a look at some known good waveforms. This is a nice looking crank signal. We'll set the camera down. We'll move this over to the cam signal. Take a look at that too. Sorry for the glare. That would be the cam signal on this thing. You can see the unique signature on it. Again, I changed my back probe connections here. I'm moving over to the TPS sensor. 1 and 2, we'll take a look at them. Alright, we're taking a look at the TPS sensors now. Key on. We're going to ease into the throttle pedal. And obviously we've acquired a signal, but it really doesn't mean much on the screen right now. It's hard to distinguish what's going on. I'm going to go up and change my time-based settings a little bit, slow this signal down so we can get more of it on the screen. We're going to ease into the throttle pedal. And what that's doing is driving a motor that turns the throttle plate. These are the sensors that indicate the position of the throttle plate. As you can see, they're opposing each other. As the throttle plate turns, one sensor goes from low to high and the other sensor goes from high to low. Nice clean looking signals. Alright, I moved my back pinning probes over to the foot pedal position sensor 1 and 2 signals. We'll take a look at them next. Now we're on the foot pedal position sensors with the key on. You notice a little bit of choppiness there on channel 1. That would be indicative of a sensor that may have potential issues. That's kind of what you're looking for. I was kind of surprised to see that on here. This is typically a known working vehicle. This vehicle has no issues. You also notice the unique characteristics of the individual signals. They're not identical. One is actually not as steep of a voltage curve as the other one. And again, I'd like to save these back to a library for future reference. That way I got some known working signals, some potential failures. I was again surprised to see that glitch in the channel 1 signal. Well, I hope you found that rather interesting, maybe a little informative. I've been working with an oscilloscope for several years now. I by no means claim to be an expert on it. I use these opportunities to practice with it. I believe it's an important part of a diagnostic arsenal, and there's many uses for an oscilloscope, and I'm finding it to be an awesome tool. Until next time, thanks for watching.